Hello students, welcome to lecture 14 of polynomials. Today we will do some practice sums regarding the division of polynomials, factor theorem, and later on with the remainder theorem and all. Okay, let me take one sum of the division of a polynomial, that is divide p of y by g of y if the polynomial p of y is equal to y cube minus 3y square minus y plus 3 and g of y is equal to y square minus 4y plus 3. Okay, now let us divide it. So I will write y cube minus 3y square minus y plus 3, and here y square minus 4y plus 3. Okay, as I taught you earlier, you will take the first term of the given polynomial p of y and divide it with the first term of the g of y. Okay, that is y cube should be divided by y square. So here only y remains. So first term of the quotient will be y. Let us multiply this y with y square. We will get y cube. This y with minus 4y, we will get minus 4y square. This y with 3, so we will get plus 3y. Changing the signs, we will cancel this. Minus 3y square plus 4y square is plus y square, because 4 minus 3 is 1, and sign of 4 is addition, so we'll get plus y square. Then minus 3y minus y is nothing but minus 4y, and let us take down this 3. Again the same step, that is the first term, this y square, okay, of this dividend is y square. Now we will divide it with y square, so we will get 1, that is plus 1. So let us write plus 1 over here. We'll multiply this one with the given g of y, that is the divisor. So what will we get? 1 means the whole divisor we can write y square into 1 is y square minus 4y plus 3. Changing the signs, we can cut the terms because they will be plus minus, and we are getting 0. So our q of y is nothing but y plus 1, and r of y is nothing but 0. We can also say that y plus 1 is the factor of the given polynomial. Correct? Now let us take some, like one more example, that is examine if y minus 3 is a factor of p of y, which is equal to y cube minus 2y square plus 3y minus 18. Okay, now see, this we will do by division method. We should know whether y minus 3 is a factor or not. That means the remainder should be 0. Okay, we will do the division method. At last I will show you one more method also. Now let us try. That is y cube minus 2y square plus 3y minus 18. Let us divide it by y minus 3. First step is first term of the dividend divided by first term of the divisor. So to get the quotient, we'll get y square. Let us multiply y square with y is y cube minus 3y square. Changing the signs, this will go, and this is plus 3y square minus 2y square is nothing but y square. Let us take down these terms, plus 3y minus 18. The same thing now, first term of the dividend divided by first term of the divisor, that is first term of g of y with first term of f of y or p of y. Okay, cut this, you will get y. So now we will have the second term of the quotient as plus y. Let us multiply this y with y minus 3. Y into y is y square. Y into 3 is minus 3y. So minus plus plus, sorry, 18 to we have not taken down yet. So we'll do only these two terms. Let us cancel this. This will become 6y minus 18. Okay, because we are bringing 18 down. Again the same thing, 6y, divide it with y gone, you are getting 6. So the last term of the quotient will be plus 6. Multiply plus 6 with y minus 3. So 6 into y is 6y. 6 into 3 is minus 18. Again changing the sign, we will get 0. So we can say that y minus 3 is the factor of given polynomial. Therefore, y minus 3 is a factor of the given polynomial p of y. You can write the whole polynomial also. Now see, this is an alternate method, but which you need to do it in the rough work when there are 2-3 numbers and you have to find the factor. Okay, see, you will not combine it. You have to do this in rough work when you don't have the factor and you want to know that which factor will go with the polynomial. This is the easiest way. Now let me take the same polynomial, y cube minus 2y square plus 3y minus 18. Okay, coefficient of y cube here is 1, y square is minus 2, y is plus 3, minus 18. Last one is. Now, they have asked us that y minus 3 is a factor or not. Okay, if they have not asked, you have to try with different factors, that is x minus 1, x plus 1, x minus 2, x plus 2 to find out the factor. But here they have asked us, so let us try. Okay. So this is y minus 3, which is equal to 0, y is equal to 3. So I will divide this coefficients with this 3. So, but first thing in this is you have to put 0 here. Every time you need to put 0 here. Now you will get 1. Okay. And 1 3s is 3. Correct? 3 minus 2 is 1. Here you don't have to change the signs. 1 3s is 3. Again 3 plus 3 is 6. 6 3s is 18. This is plus 18. This is minus 18. So 0. As we are getting 0 at the end, we can say y minus 3 is the factor. And now see, the beauty of this method is, because I am getting 1, 1, 6. Now listen to me very carefully. The polynomial is y cube minus 2y square plus 3y minus 18. Here now I am getting the coefficient as 1 plus 1 plus 6. See, this is just an explanation. You don't have to add. 1 means the coefficient of y cube. But this is the quotient. We are getting the quotient. So you have to decrease the power. 1 means the quotient of y cube, but the power will be y square. Okay. Here again the coefficient is 1, but the variable is of power 2. But here it will become plus y and plus 6. This is your quotient. You will directly get your quotient like this. Now see, have you got that quotient here? Y square plus y plus 6? Yes. This is the another way of checking for the factor of the given polynomial. In 2-3 sums, we will do this method in the rough work, so you will understand. Okay. This you need to do it in the rough work. Now, one more example. That is, we will see that use the factor theorem to determine whether x minus 1 is a factor of First is the polynomial given is x cube plus 8x square minus 7x minus 2. First polynomial is this, and the second polynomial we take later on. Now they are saying that we have to check whether x minus 1 is a factor. Now, if you want to check that x minus 1 is a factor, your remainder according to the factor theorem should be 0. That means if I take x minus 1 is equal to 0 and x is equal to 1, okay, I will get p of 1 as 1 raised to 3 plus 8 into 1 square minus 7 into 1 minus 2. This is 1 plus 8 minus 7 minus 9. Minus 2. This is 9 minus 9. This is 0. So I am getting my remainder as 0. That is, here I am getting p of alpha as 0 according to the factor theorem. Hence I can say that x minus 1 is a factor of the given polynomial p of x. Okay. Now let me take the second polynomial. That is p of x is equal to x cube minus 27x square plus 8x plus 18. Now the same thing. That is x minus 1 is equal to 0. X is equal to 1. See, this is just for your understanding. Okay. Now let me write p of 1 as 1 cube minus 27 into 1 square plus 8 of x plus 18. That is equal to, am I making any mistake here? Sign mistake is there? No. So we'll get 1 minus 27 plus 8 plus 18. This is nothing but minus 26 plus 26, 0. Again the same thing. According to the factor theorem, p of alpha should be equal to 0 if you want x minus 1 or x minus alpha as a factor. This condition is satisfied. Therefore, x minus 1 is a factor of the given polynomial p of x. Okay, so these were some sums. We'll do more sums in next lecture. Please do these sums. Please understand them. Do the similar kind of sums from the practice books you have. I will send some practice sums also. Okay, so we'll meet in next lecture, and thank you very much. And also share our channel too with